So today we're going to be doing a lab called the specific heat of a metal, and our goal today is going to be to find out the density of this metal that's wrapped in purple tape by finding two intensive properties. One is the specific heat capacity, the other property is the density of the metal. So we're going to start out by getting the mass of this metal. So I have my balance right here, and the mass of this metal is 68.11 grams. I'm going to take my tongs and place it into the boiling water bath. Now, we know that water boils at 100 degrees, so once this has been in here for about 5 minutes, we can say that the metal is going to be starting its journey at 100 degrees Celsius. Now, in addition to that, we're also going to be using a calorimeter. So, a calorimeter is a well-insulated container. Ours looks like this. It has a lid, and then inside I have a thermometer, and I have a stirring stick, and I have a cup inside. Okay, so this is just empty. The air around it is insulated. Now, what I did ahead of time is that I have measured this cup empty, and then I put some water in it. And I only put enough water in that it's going to cover our metal once we place it inside. Okay, so I'm going to set this back up, put my stir stick in, and put my thermometer in. The large hole here is for the stir stick, and the small one is for the thermometer, and that's just going to hold it in place. Now, what we do need to find is the temperature of our water initially. So it's creeping up, and while that reaches its equilibrium temperature, I'm just going to show you some other that I have set up. Now, I already have a graduated cylinder with some water in it that I'm going to use to find the volume of this substance. Now, both density and specific heat capacity are intensive physical properties. That means we can use them to identify this metal that we're looking at. So I've made some recordings in my data table. I already have the mass of the metal, the starting temperature of the metal, 100 degrees C, because it's in a boiling water bath. I have the empty cup and the cup with the water in it, and the starting temperature of the water, which is coming up to 19.9 degrees Celsius right now. I also recorded the volume of the water so that we can find the density later. Now, specific heat capacity is the amount of energy needed to raise 1 gram of a substance by 1 degree Celsius. We use the symbol C to represent the specific heat capacity. And we're going to be finding the heat for this. Now, one important factor in this lab is we know that the heat lost by the metal is going to be gained by the water when we put the metal into the water in the calorimeter. So we're going to be able to measure the amount of heat lost by the metal by looking at how much heat is gained by the water in the calorimeter. And I'm going to transfer this over as quickly as possible, get the cap back on, and I'm going to be stirring this. Now, what I care about is finding the highest temperature that the water reaches. And this happens fairly quickly. I'm going to give it a stir. I could stir it with my thermometer. We're already up to 23 degrees. We're not anticipating a huge jump, probably less than 10 degrees. I'm at 23.3, 23.4, 23.5. Now, it's important to stir this so you don't have areas that are hot and areas that are cold. 23.8, and it looks like we're maybe stopping there because it doesn't seem to be changing much. Now, you want to keep recording until you get the highest temperature. Oh, we had another jump. And once it starts to decrease, you can stop and call that your highest temperature. .9 looks like as high as we're getting. Okay, so we're going to record our highest temperature of 23.9 because it's already started to decrease. Now you can see that I've recorded my final temperature of my metal and my final temperature of my water, and both of those are the highest temperature that the water reach, which is the 23.9 degrees Celsius. That's because once this is finished equilibrating, so that the metal has given off all its energy to the water, the two substances are going to be the same temperature. Now the last part that we're going to do in terms of gathering our data will be getting the volume of this metal. And you're just going to find a volume by water displacement. My initial volume here is 54.8 milliliters, plus or minus 0.5 milliliters. And I'm going to put this metal in by tilting the graduated cylinder and sliding it down the side. Now, you do that for two reasons. You don't want to splash the water out, but you also don't want to break my graduated cylinder, because that would make your teacher rather upset. Now, I'm reading this at eye level, and it appears that it is approximately 64.7 milliliters.